Hi, my name is Dominika Basaj. I'm working in Tooploox. This is a software house company that provides AI solutions to startups and innovative corporations. And today I would like to tell you a little bit about why I think, although the progress in NLP is amazing, the models actually do not work in the wild. So I'm pretty sure that most of people here know these two little guys who started the revolution like around 2018. And right now, thanks to contextual and character-based language models, we can actually, some models really surpass humans on certain tasks. So it sounds great. However, the plot thickens a little bit because humans can break these models. And it might make an interesting plot for a tacky sci-fi movie, but we don't really want this kind of situation on production environment, right? So to give you an idea of what might actually break our model, let's take a look at that. So this is actually a true excerpt from my conversation, and after that I called, and who hasn't been there trying to send the right message. And this is where we move to a more serious environment. And actually my favorite type of tasks, which is question answering, that was mentioned here some time ago. So during my research, I kind of showed that, and not only me, but actually there is a huge community around that, that small mistakes that are not so important for humans can make a lot of mess with the model. And sometimes, in case of question answering, models are so overfitted to the training data that you can remove everything except for one word from the question, and the answer is still correct. But of course, the question remains whether there even was a question. So how can we actually say whether the model was good or whether we should proceed to the production with the model? Well, it's not such an easy question because NLP is unfortunately a little bit behind computer vision. And last year at iClear, there were two computer vision researchers who published a benchmarking schema for robustness testing of computer vision and images. Unfortunately, in NLP, we're not there yet. And there is no unified benchmark for that. So this model comparison is maybe not possible, but it's actually very hard, because if there is a research paper on adversarial robustness, everyone is doing tests on their own examples. So that's what we are trying to achieve with WildNLP. Is to actually create some kind of unified framework for this robustness testing and training. And we would like it to, it will consist of three elements. The first one, these are designed attacks that are kind of a byproduct of our research analysis of robustness of BERT and ELMO and all these state-of-the-art models. And it kind of elevates the problem, but the even more important part is the second part, when we'll soon introduce generation of natural errors with grammatical errors or lexical errors. And the third one, which is like a holy grail, is to create adversarial robustness training framework that does not consist only of enriching the training set, because what we showed in the research is not enough, but we want to take advantage of similar representations. And I can go into details at the poster and after the talk, because it's only a spotlight. So what we have here are the design perturbations, and this is like the first attempt that we're aware of that gives a unified framework for testing whether your model is correct. It's super easy to use and you can take it off the shelf, which is very handy in a business POC type of situation where you really have to prove pretty fast that you're doing the right thing. Recently, we also included OCR mistakes, which is very helpful when you're doing some kind of classification from images or anything like that. And these two are going to be here soon. And I can promise you that because this is part of my PhD, so I'm very, I'm very into doing this soon. And basically, you can ask a question whether we should be worried about that because we are aware that these models do not get 100% accuracy. So maybe there is nothing to worry if that performance drops a little bit. However, I must say that the performance might drop really a lot. So here we were. This is like this is part of our paper, and we were testing BERT, Elmo, and Glove question answering task. And actually, when we were introducing these perturbations, so-called adversarial examples, we saw that the performance drops even by 40 percentage points, which is actually quite a lot. It was not surprising in terms of Glove because this is a simple out-of-vocab type of embedding, but we were really surprised that with BERT and Elmo, which are first of all contextualized, and second of all it's character-based, it was still not enough to make the model robust. So this is due to extreme overfitting to the training set, and the whole community is checking on the test set that, well, is kind of exploited in many situations. These datasets are very specific and they do not show enough phenomena that is out there. And what I would like you to actually really remember is that this great performance does not equal generalization, which in business scenario, of course, is crucial. So thank you very much. Yeah, that's it, I guess. Thank you.
Thank you.